In this video, I'm going to give you an introduction to the Solidity programming language so that you can become a blockchain developer. And it doesn't matter if you're brand new to blockchain or if you're just learning to code. I'm going to teach you everything from scratch. I'm also going to show you how to do this directly inside your web browser so that you can get started quickly. You won't have to install any special software on your computer to get started. And the best part is, I'm going to show you the most updated version of Solidity because a lot has changed. And finally, this is video number 1 of a series that I'm going to release over a few weeks on my YouTube channel. So make sure you subscribe and click the like button down below so you can catch those videos when they come out. So before we get into all that, if you're new around here, hey, I'm Gregory from Dapp University, and on this channel, I teach you how to become a blockchain master. So if that's something that you're interested in, then head on over to dappuniversity.com/bootcamp. Solidity is the main programming language used for writing Ethereum smart contracts. It's object-oriented, and it looks a lot like other common programming languages such as C++, Python, and JavaScript. So if you're familiar with any of these languages already, then you're going to have a huge advantage learning Solidity. So it's statically typed as opposed to dynamically typed. It supports inheritance and also libraries. So don't worry if you don't understand what these things mean just yet. You're going to learn all those things inside this tutorial series. And let me quickly mention that we're going to use the latest major version of Solidity for the year 2020 in this tutorial. So we're going to focus on version 0.6. And that's one of the big benefits of this tutorial series is the blockchain landscape is constantly changing. Solidity is always updating new versions. And I'm going to educate you in all those changes inside this video. This is a website that allows you to write Ethereum smart contracts directly in your browser. This is Remix, so head on over to remix.ethereum.org to get started and follow along with me in this video. So if you used Remix before, you might notice that this has changed quite a bit from previous versions of Remix, and that's another reason I want to make this video is to show you what those changes are and how to use the new version of Remix, all right? And so if you haven't used Remix before, let me quickly explain what it is. It's a browser-based IDE that lets you develop smart contracts directly in your browser. You don't have to install anything on your computer to get started. You don't have to use a terminal. You don't have to use a text editor or anything like that. You can do everything here. So you can create new files like this. I'll show you. You can go here to the sidebar and click the plus icon. All right. I'm going to go ahead and create a new file here called counter. All right. Counter with a capital C .sol. This is the file extension for the Solidity programming language, .sol, and it's convention to capitalize the name of your smart contract files whenever you create them, okay? So I'll click OK, and here we go. This is the file that we'll use to write all the Solidity source code for the smart contract. And I'll get back to that in a second, but I want to continue on with the tour here of the new version of Remix. So you can create new files for your smart contracts. You can see that there's some already saved here. All right, this is a storage smart contract, okay? There's an owner smart contract, a ballot. So you could even learn a lot about Solidity just by reading through some of the examples that are provided here inside of Remix. But I'm going to show you how to build a smart contract from scratch, step by step in this tutorial. And I'm also going to take you through many different features of the Solidity programming language throughout this series. So in addition to writing smart contracts inside these files, Remix allows you to do a lot more things like compile the smart contracts, deploy them to a blockchain, and actually run a blockchain inside your browser. So Remix is actually a fully fledged IDE. So if you're using this brand new version of Remix, you might have to configure some things yourself. It may look really bare, where you can only see these files and a plugin manager. So I'm going to tab over to a separate terminal window, or excuse me, a separate browser window that I use in my regular Remix setup, which you can see I've got a lot of other things configured. Like here's the files, here's the compiler, and things like that. So I'm going to show you how to add these plugins to your environment so that you can do the same things that I'm going to do in this tutorial. So let's go here to the plugin manager, and let's look for compile, Solidity compiler, click activate. And next, do deploy and run transactions. So just search for deploy, and it should be the first thing that comes up. So deploy and run transactions, click activate. And there you go. Those are all the plugins that you'll need for now in order to follow along with me. So I'll show you what they do. First, this is the compiler. This, takes your source code and compiles it down to bytecode that can be run on the Ethereum virtual machine. And I'll explain that more when we get to that step. And then finally, this allows you to actually run a blockchain in your browser right here. You can see the environment is a JavaScript virtual machine, which basically means it's a virtual blockchain. And it gives you several accounts, and we'll go over all this here in a minute. But I just want to give you a quick tour of Remix and how it works and how to get set up so you don't get stuck if you see the new version of Remix and don't quite know how to use it. All right, so let's get started. Open up your counter.sol file that we created a minute ago and go ahead and do this at the top. Say pragma, Solidity, and then a caret, version 0.6.0, followed by a semicolon. So this line just tells the Solidity compiler which version of the Solidity programming language that we want to use. This must be the first line inside of our file, and we must declare the version like this. Next, we declare the smart contract like this. We say contract, capital C, counter, and then we do an open curly brace, hit enter for a new line, and it should automatically create the closing curly brace for you. All right, if not, you can just type it manually like this. So this is the basic skeleton for the smart contract. We use this contract keyword to declare it, and then we give it a name. Counter is the actual name of our smart contract. And then all the source code for the smart contract will go inside of here. And then all the rest of the code for the smart contract will go inside these curly braces. All right, so the first thing that I want to do is create a basic variable inside of Solidity. So if you're brand new to programming, variables are how we store information. And specifically inside Solidity, we create variables to store things like numbers, strings of text, and all different kinds of things. All right. So I'm going to show you how to do this right now. We'll say, a variable can look like this. We just give it a name like count. We're going to store a basic value for this counter smart contract. Okay. So we're going to follow it by a semicolon, but also we have to give it a type. All right. We have to tell Solidity what kind of information is inside this variable. So in this case, it's going to be a number, all right? And Solidity doesn't have something called number like this. It has something called uint, all right? So uint stands for unsigned integer. So if you think about an integer like, 1, 2, 3, et cetera, et cetera. Well, let me actually do that in comment that out here just so they don't get confused. Like 1, 2, 3, ... These could be integers, but unsigned integer also means that it can't be positive or negative. Sorry, it can't be negative, which means it can't have a sign in front of it or a minus sign, all right? So it means a positive integer. And that's what this smart contract's going to do. It's going to take this number, we're going to be able to read it out from the blockchain, and we're also going to be able to increment this. So think maybe you have an app on your phone where you're playing a game and you want to keep track of the current score. You could use something like this. You could just increment the value by 1. And that's exactly what I'm going to show you how to do. So next, I'll show you how to read the count from the smart contract. We're going to create a function like this. Say function get count. All right, and we follow that by parentheses like this and curly braces. All right. So a function is just a way to create reusable code inside of a smart contract that performs some sort of operation. So inside this function, what it's going to do is actually read this count from this variable and return it back to us so that we can, inspect its value. So if you're going to use this counter to keep score in a game, for example, and you want to know the current score, well, you can call this get count function to return the current score. All right. So we can do that just like this. We say return count. This is just a special keyword inside of Solidity. Whenever you finish a function, you say return, and then you give it the value that you want to return. In this case, it's the current count. Okay. So next, what we want to do is make this function accessible outside of the smart contract. So we must do this. We say public. So this is the visibility of the function. All right, there's several different things we could do here. We could say this is internal, or we could just not put anything here. We'll learn more about that in the series, but for now, just know that we must use the public modifier here in order to call this function on the smart contract in our browser here in a moment. All right. Next, we add view here, which really just means that we want to view the value of this count here, we don't actually want to change it. And it means something more complex than that, which we'll find out more in the series. But that's essentially what you need to know for now. This just views the count. It doesn't actually change the count. All right. And then so finally, we want to specify the type of data that gets returned here whenever we say, return count. So we say returns and then a uint. All right, because we said this was a uint here, or unsigned integer, and we want to specify that it also returns a uint here with this function. So next, what I want to do is create a function that actually changes the count, okay? So this function gets the count, all right, and this is the variable where we store the count. And then finally, we want to create a function that actually updates this count. So we can say function increment count, okay? And we follow it by open and close parentheses. And this one will also be public, just like the previous function, because we want to be able to call this function outside the smart contract. We'll be able to use it in our browser, which we'll see momentarily. All right, and we'll do an open and close curly braces, just like the last function. And then everything that we'll do inside this function goes here. So inside of here, all we want to do is change this count by 1, okay? So we can say count, which references this right here, equals, we'll update it. We'll say count, the current count, plus 1, followed by a semicolon. So whenever we call this function, we're going to take the count and add 1 to it. So anytime we do this, it'll just be like a counter that you might use to keep score in a game, which I talked about a minute ago. So let me talk really quickly about this count variable. So this is a special type of variable called a state variable. The count value actually gets stored to the blockchain itself. All right, so whenever we put this smart contract on the blockchain and we update this count amount, it actually gets saved to the blockchain and we can read its value later. All right, so there are different types of variables in Solidity. There are local variables that you might just see inside of a function, but there's also variables that are more permanent, and that's what state variables are. We have to actually store this value on the blockchain and read it off. So whenever we call this function, we're actually updating the blockchain. We're updating its state, all right? So you'll see here, we used a view modifier for this function. We don't use view here because whenever we call this function, we're actually going to change the state of the blockchain whenever we update this count. So more on that in a minute, but I just want to make a quick note of that while we're here. Now we want to set an initial value for this count. All right, we're returning the value and adding 1 to it, but we want a starting point and we want to specify what it is. So we're going to use something called a constructor function to do this. All right, so that looks like this: constructor, public, and then open and close curly braces. So this is a special function that looks different from these other functions that we just created a minute ago. This is a function that gets run once and only once whenever this smart contract is deployed to the blockchain. So any code that we write inside of here will execute whenever we put this smart contract on the blockchain. So in this case, what we want to do is just set the count value. And we're going to say count equals 0. All right, so that's going to be very explicit that we're starting at 0 whenever we, use our counter. And then when we add 1 with increment count, it'll go to 1. And then, every time we click this, this will change by 1, but we start at 0. And then we can fetch the count like this. And also note that we must use the public modifier on this constructor so that it can be run in the migration. All right, so that's our basic smart contract for now. We're going to come back and modify this code here in a minute, but what I want to do now is actually compile the smart contract and put it on a blockchain so that you can use it and actually observe how the code works that we just wrote, okay? So go to this first plugin, all right? This is the compiler plugin that we added a minute ago. Click compile, all right? Make sure you have 0.6.1 selected here first. Compile. Oops, it looks like I have a typo here. I can't believe I've had that the entire video. That's okay. So Pragma, P-R-A-G-M-A, Solidity version 0.6.0. Sorry, everybody, if you've been sitting here staring at this the entire time, wondering how I'm going to fix this. Here you go. All right, so let's try it again. Click compile. And there we go. So let me explain the compilation step. Essentially what this does is it takes your human readable code and it compiles it down to machine readable code. All right, so you can see, let's see here. Click on bytecode, and this shows you, what the value looks like. So I'm actually going to open this in my text editor here, and you can see this is what you get whenever you compile this down to bytecode. All right. Next, let's go ahead and deploy it to our virtual blockchain. So click this icon here, and make sure you click JavaScript Virtual Machine, and make sure you have your smart contract selected, and click Deploy. All right, there you go. That's how easy it is to deploy the smart contract to your virtual blockchain. So you can see the deployed instance of the smart contract here. All right, you can see our two functions. So increment count and get count. So let's click the get count button. This calls it and should return 0 like we expect it to. All right, so you can get count. All right, there you go, 0. And increment count. All right, so then let's get count again. All right, there you go, boom. Try it again, get count, 2. Awesome, it's working. So let me mention this. This is the sort of transaction log that you can see for the smart contract on the blockchain here. So remember when I said we create a transaction whenever you do increment count here? That essentially means that you're, writing data to the blockchain. So the blockchain is, basically comprised of bundles of records called transactions. So every record on the blockchain is essentially a transaction, and those groupings of transactions are contained in bundles of records called blocks, which are chained together to make up the blockchain, okay? So you can see all the transactions that go through right here. And anytime that we create transactions, we must pay a gas fee. So you can see our account here has gone down. So the rest of these accounts start with 100, but this particular account has gone down, and it will every single time that we do that. So increment count again and again, and our balance keeps changing, okay? Because we're paying for gas anytime we update the state of the blockchain, and we call this increment count function. All right, so that's how you deploy the smart contract to the blockchain and use it and call its functions. Next, I want to show you how to refactor this code a little bit. All right, so the first thing I want to do is actually get rid of this constructor and show you that you can just set the default value of the count here. So you can just say count 0. All right, we can remove the constructor function like this. And then we can just click compile. All right, still works, and deploy. And get count is 0, increment count. All right, it's changing. So we can, change this value to 1 if we wanted to. We can start at 1. Click deploy again. We can skip the compilation step. All right, and see here, get count by default. Actually, let me try that again. We do have to compile. Let's do this. Deploy. Get count. All right, it's 1 by default. Awesome. And increment count still works. Okay, so next what we can do is remove this function and do it automatically with the variable, okay? So instead of, creating a function like this to return the count, we can just call this public. So we can say uint public count equals 1, all right? And that removes this function's need entirely. So let me tell you what that does. This assigns the visibility of this state variable to public, just like these functions are public. And whenever you do that on a state variable, Solidity automatically generates a function for you behind the scenes that gives you this variable value. So I'll show you what that looks like. We'll just click compile, and then I'm going to delete this, click deploy. And now you can see that there is a function called count here, which automatically returns the value. Okay, so increment count, and then count. Perfect. So next what I want to do is refactor this function a little bit. So change it. And instead of doing count equals count plus 1 here, we're going to say count like this, plus plus. And that should automatically increment the count for us. So that means it's just a shorthand way of saying add 1 to the current value of count. All right. So I'm going to compile that. And then clear this out and do deploy. All right, count, increment count, goes up by 2, or goes up by 1, 2, 2, 3. All right, it works. So that greatly simplifies the code for the smart contract. It reduces the amount of code we actually have to write in order to achieve the same types of results. But I think it's really valuable to see how everything works the long way first so that you better understand what the short way does. All right. So that's an introduction to the Solidity programming language. Congratulations, you just written your first smart contract. So I hope you like this video. So go ahead and subscribe to the channel and click the like button down below. That'll help you find out about the next videos in this series whenever they come out. And as always, if you want to take that next step to becoming a blockchain master, then head on over to dappuniversity.com/bootcamp. All right, until next time, thanks for watching Dapp University.